Hello, period 6. We'll be going over the guided practice problems for lesson 9.3a, solve quadratic equations by graphing. We're going to start with making a key concept chart so that we can see how the parabola graphed on a coordinate plane relates to the number of solutions that that quadratic equation set equal to 0 will have. We'll see on the left coordinate plane with the parabola graphed that the parabola intersects or crosses over the x-axis in two places. There are two x-intercepts, and therefore there will be two solutions to the quadratic equation set equal to 0 in that case. In the middle of the key concept chart, you will see a parabola that is opening upward and just reaching down and touching the x-axis at one point. If our quadratic equations graphs into that situation where the parabola touches the x-axis at only one point, there is only one x-intercept. That means there will be one solution to the quadratic equation. Finally, on the right-hand part of our key concept chart, we see a parabola that is opening upward above the x-axis. There are no x-intercepts, so in that case, there would be no solutions to the quadratic equation set equal to 0. So the key concept chart should be on your paperwork. The only part of the key concept chart we will be focusing on for this lesson in this class will be the left one, where the parabola intersects the x-axis at two places, providing two solutions. So let's take a look at what that means. We'll take a look at example 1, well actually the problem above example 1, where it asks us to solve x squared minus 6x plus 5 equal to 0 by both factoring and graphing. So we're going to see how factoring the quadratic equation, which gives us two solutions to this equation, how it then relates to what the graph looks like for this quadratic equation. So noticing using our x method that we can factor this quadratic equation into x minus 5 times x minus 1 is equal to 0. Setting each of those factors equal to 0 and solving those resulting equations provides us with the two values for x that solve the equation. Those two values are x equals 5 or x equals 1. Now we're going to use that information, those x values, which are the zeros of the function, we're going to use them to create our graph so we can see how x equals 5 and x equals 1 shows up on the graph of our quadratic equation when instead of setting x squared minus 6x plus 5 equal to 0, we're going to set it equal to y as you see on the right-hand side of this screen. So again, we know the two x-intercepts from our factoring is x equals 5 or 1, and we know that the vertex of that quadratic equation will be halfway between those two x values. So to find that number that's halfway between 5 and 1, if that's not already obvious that it's 3, in some cases it will be obvious that number exactly halfway in between our x-intercepts. Sometimes it will not be obvious. So to find that number halfway in between 5 and 1, you can go ahead and add those two numbers up, 5 plus 1, then divide by 2, since you are finding the middle of those two numbers. You're averaging those two numbers. So 5 plus 1 over 2 equals 6 over 2, which simplifies down to 3, and that x value 3 becomes the x-coordinate of the vertex of the parabola that you are going to be graphing in a moment. Now, below 3, put 1, and above 3, put 5 in your table of values. And the reason you're putting x is 1 and x is 5 is because you already know that when x is 1 or 5, that y is 0. And we figured that out when we used factoring to solve our quadratic equation on the left. So in the middle of my table of values, I have worked out those values for y. I really didn't need to work out the value when x is 1 and x is 5, but I'm showing you how that works in the table of values. Now we're going to graph that quadratic equation based on our table of values. We're only going to use 3 points instead of the typical 5. That will be enough to know where that parabola is. The point of what we're doing is seeing how the values of x that solve the quadratic equation when it's equal to 0, what it looks like when we graph it on a coordinate plane. So we are plotting 1, 0, and 5, 0 on the x-axis. Those are the x-intercepts. They are the solutions to the quadratic equation. And then we're also plotting the vertex and drawing our parabola through those 3 points. 3 points will be sufficient for what we're doing here. So that means that we can look at our graph now and notice that the solutions to the quadratic equation must be 1 and 5 because 1, 0, and 5, 0 are the x-intercepts for this graph. We'll do one more example together. That's example 1. And it's going to be the same process. Solve x squared minus 2x equals 3 by graphing. First, we'll subtract 3 on both sides of our equation to get it equal to 0. So we can use our x method to rewrite this quadratic equation in factored form. That factored form is x minus 3 times x plus 1 is equal to 0. We'll set each of those factors equal to 0 and determine that the values that solve this quadratic equation set equal to 0 is x equals 3 and x equals negative 1. We're then going to make the graph, and instead of setting x squared minus 2x minus 3 equal to 0, we're going to set it equal to y to find out what the graph looks like on a coordinate plane. We will need to find the vertex x-coordinate of that graph. We will find that by finding the value that is exactly halfway in between our x-intercepts. That is the x values that we got when we solved our quadratic equation set equal to 0. So the x values that solve the equation are negative 1 and 3. We will average those two numbers. That is, we'll find the number exactly halfway in between negative 1 and 3 by adding negative 1 plus 3 and dividing it by 2. That's going to give us a vertex x-coordinate of 1, which you see in my table of values. Then I put the x values that I worked out when I solved my quadratic equation by factoring. I will put my x as negative 1 and positive 3 in my table of values also. Notice this time I didn't work out the y values when x is negative 1 and 3 because I already know that the y values are 0. I found that out when I was using factoring and using the zero product property to solve the equation. I will need to figure out the y coordinate that corresponds to my vertex x of 1. And you can see that I worked that out on my table of values. When x is 1, y is negative 4. Now I'm going to plot all 3 of those points. Again, I'm only using 3 points for this lesson. That's all that's necessary. My two x-intercepts are negative 1, 0 and 3, 0. Those are the solutions to the quadratic equation. My vertex is at 1, negative 4, which again you can see on my parabola as I've graphed. So there's 2 solutions because there's 2 x-intercepts. Now I'm excusing you from the rest of the examples here. I do have them uploaded for you. I'm not going to talk you through these because I'm not holding you responsible for example 2, where I demonstrate what happens when you graph your parabola and it touches the x-axis at only one point, meaning that there would be only one solution to the quadratic equation. Again, example 2 does not need to be recorded in your paperwork. Example 3 shows what happens when you graph your quadratic equation using the vertex x-coordinate value of negative b over 2a, since this one won't factor. Anyways, you'll see the table of values worked out there and the graph of that, and you'll see that the parabola never touches the x-axis, so there's no solution. Once again, I am excusing you from example 2 and example 3. You may record those if you want on your paperwork, but it is not necessary. The only types of problems that you have been assigned in your homework are like example 1, and then the first problem we did is also like example 1, where you will be using factoring to find your x-coordinates of the parabola that you're graphing, and then you'll find the vertex halfway in between those 2 points. You will report the parabola. As part of your answer, you'll show the graph that will then show that the values that you worked out for your x values are in fact the x-intercepts. Okay, so it's now onto your homework. You only have a few problems to practice this way so that you can understand that the parabola can show the values that will solve the quadratic equation equal to 0. All right, thank you. Talk to you later.